to visualizations. With our visualizations, there's a website that I've included in the notes to a place called DataViz Catalog. And DataViz Catalog is basically it's a website that pulls together all the different types of visualizations that you could come across when you're trying to share data. So the most common one that you've probably dealt with before is a bar chart, right, showing either a proportion or a distribution, something along those lines. And so this website will show you what a bar chart is and when to use it and things like that. What's really neat is it shows you, you can search by function, and it will tell you, hey, different visualizations are appropriate for different types of data and different types of analysis. So if you're trying to do a proportional analysis, okay, you might use a stacked graph, a stacked bar graph. Okay, so this shows you, hey, this is the percentage that's being used over time of this particular object. You have pie charts. Pie charts are evil and you should never use them. Same thing goes with donut graphs because they're just pie charts with a hole missing. Right here, these guys, donut charts. Donut charts and pie charts are favored by marketing people who like to fill space with stuff. But generally speaking, pie charts are very, very hard to interpret. For example, if I look at this pie chart, what percentage of my pie is this if it's not labeled? Looks like roughly, I don't know, 20, 30%, somewhere in there. Okay, great. I could do the same thing on a bar chart that has a scale, like here's my 50%, and I could show this data in a lot more concise graph that's much easier to interpret. And the worst part is people try to be clever with their visualizations, and they take that pie chart and they make it 3D. Right? So then you've got this graph, and now all of a sudden, this piece looks like a giant piece of the pie. Actually, it looks smaller at an angle, but because you've got like the width of it, or the depth of it, it distorts the data. Everything in the back looks smaller, even though it is an appropriate size, which tells you you should never ever use pie charts, and you should never ever use 3D, because 3D is purposely distorting the data. Okay, so you could use that, donut graph, or you could simply use a stacked bar graph, and you can show so much more information in that same amount of space. That's much more useful and relevant. You can show comparisons and trends over time. Whereas if you tried to show that same graph and say, oh, look, here it is this period, and here it is next period. Like, how much did it change from there to there? It's really hard to interpret these. By the way, PwC is the worst with these donut graphs things. They try to be clever, but no. Okay. Speaking of distorted graphs, word clouds. Have you seen these before? They're very popular. They're very cool because you can see the distribution of words roughly. Again, it doesn't give us any description of you just know the bigger ones show up more frequently. Okay. So if I have these two words, and let's assume that they're the same size letters, which one of those looks like it would be bigger or more important? The longer one. Not only is it long, it's twice as long, but it also has a little tail on the P. So when you have capital letters or lowercase letters or Q's versus E's, you distort the proportion. Again, these are not meant to be scientific by any means. They're just an illustrative purpose. But again, state versus good or one, it's hard to distinguish what's going on between the two. All right. Speaking of proportion, tree maps are really, really cool for showing proportions. This is like looking at your pie chart, but when you have lots of pieces in the pie, because you can quickly see which are the big companies versus the small ones. I'll give you an example. There's a website here called rankandfile.com. This is a website that allows you to explore SEC filings, so 10Ks, annual reports, quarterly reports, and so forth. And if we explore it, here we can see a tree diagram that shows the proportion of companies based on, I think this is market cap that it bases it on. So the most valuable companies as a group are in finance, consumer services, healthcare, technology. Right? But that's as a group. Apple has the highest market cap, and it's a technology company. We come into technology, and we look at NASDAQ versus New York Stock Exchange. NASDAQ, most technology companies here. Here's Apple, compared with Cisco, or Google, or Adobe. So you can see the relative proportional value of these companies. The big players versus all these little teeny tiny players all hanging out here. You also have a heat map here showing the different companies. Okay, where are most companies incorporated? If the darker value means more companies. California, New York, and Texas. What's wrong with this visualization? Okay, you can't tell it's darker. Let's assume that they're all, roughly here. We're talking about absolute numbers, and we have states that are proportionally bigger than all the other little states, like New Jersey and Massachusetts. Okay? Maps are very, very deceiving. Let me give you another example. The New York Times. Okay, the New York Times does a lot with visualizations. They have some really interesting things. So here is the results from the midterm elections. This was last year's election. Okay. And so we have, I'm going to make this not dark here for a sec, so we can blind you. There we go. All right, so here's a map showing the House of Representatives elections. If you were looking at this map, you would say, hey, most of the elections went to red Republicans. But in the United States, each district represents roughly the same number of people. So Montana, right here, has the same number of people as Allegheny County, right down there, Pittsburgh, District 18. So this map, geographic maps can be very deceptive. So an alternative here, they have a cartogram. This shows each of the districts as the same size square, and they've arranged it so that it matches roughly the geographic space of different states. Now, if you look at it, it looks more blue than red. Yes. The stripy ones are, those are ones where they flip. They went from a Republican to a Democrat or a Democrat to a Republican. Okay. So if it changed seats from one to the other. So anyways, basically blue versus red. So you have to choose the correct visual to take out the bias or the distortion from the data to share something nice. The problem is people really love maps. Maps are pretty. You can understand what maps are. Cartograms, a little bit harder to figure out, but less biased than what you'd expect. Okay, so you can look at different types of maps, different types of diagrams to figure out how you can visually represent things. Also, another popular thing in Tableau, they like to use size. So in addition to the 2 dimensions of where it plots out on the graph, if there's a third dimension you want, you can use size or you can use color to add additional depth to your visualization. We'll look at this when we do our visualization lab on Wednesday. Okay. So this is worth checking out, the data visualization catalog, trying to see what are, oh, there was that dot matrix one. The dot matrix chart, that's the showing things as a proportional dot. Okay. So we'll explore some of these when we get into our lab on Wednesday. But the key thing is that you want to choose visualizations that are as free from bias as possible, unless, of course, you're trying to bias the response. But as accountants, you're not, right? We have this whole framework of faithful representation relevance and reliability that we're trying to uphold. So we have different standards there. Okay, so data viz. One other thing I want to show you here. So in our lab on Wednesday, we're going to be using Tableau. How many of you have used Tableau before? Okay, so a couple. Tableau is software that is designed to help you create visualizations. It's a fairly easy interface. It is incredibly difficult software to master because it's deceptively, it looks easy, but being able to put the data in a way that visually represents your data appropriately is challenging. So we'll look at that and figure out how that works. A competitor to Tableau is Power BI. This is Microsoft's version of Tableau. And Power BI, you can go to powerbi.com and log in with your PIT ID, and you can do some analysis, some basic analysis there. You can also download desktop software that's more powerful. So the advantage here is that here I've got, this is just some sample data set that they have put together. And here's a dashboard. It shows multiple visualizations that I can explore and hover over and see the values of these different business units and so forth. So here we have gross margin percentage. This is looking at each of the different business units. And the dark color is my budget. The light color is my actual. What kind of visualization or analytics is that of the four categories? If I'm comparing actual to budget. Is it descriptive, diagnostic, predictive, or prescriptive? Yeah, diagnostic. All right, we're seeing how we compare to our norm. Over here, we also have a diagnostic one. The red bar here is the budget, the target for sales in this case. And then we have a range of low, mid, and high values. This is kind of like a odometer, right? So you can say, hey, Carlos, he's in the green zone, but he hasn't quite met the target. This is called a bullet graph. These are really, really powerful. You should look into them. We may be able to do some of them on Wednesday. Okay, but again, we're comparing our actual results to what our expectations are and seeing how that works. The thing that comes in handy here is that in addition to creating these visualizations, there's a push towards natural language analytics. So instead of having to know which columns and fields to put wherever you're supposed to go, you can say, all right, I'm going to ask a question like, what is the gross margin? What is the gross margin by customer? And it's going to create a graph for me automatically based on my question. I don't have to say, select this from there, do that. I don't have to drag customer here and the value here and do all the statistics. As a pie chart. Hey, see, isn't that a great pie chart? Look how awesome that is. Okay. As a matrix. So if you figure out how to phrase these questions, you can create some really interesting by customer, sorted by name. So you can start answering these questions. There's a lot of push into doing this so they can take your language and predict what it is you're trying to do so that people who are not good at data can ask questions. You still have to know whether the data is good or not. Yes? This is data there's a data set in Power BI that Microsoft has provided for you to play around in. So I'm just asking it, what are some of these different things. So you have to know what the data is that's in there to be able to ask the questions. But once it's there, so the alternative to that is I can create a new, let's see, let me come and edit this. If I create a new tile with no, go back. Oh, here, let's go back to my workspace. Oh, that's not what I want either. Da, 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 da. All right, well, we'll come back to that. Anyways, so you can create all these different visualizations by dragging and dropping or by using this. Tableau, with their newest version, has also introduced natural language processing. So you can ask the question to at least start the analysis, and then you can tweak it with the colors and the phrases and the different attributes and data values that you're using. All right? So this is kind of where we're headed in terms of visualizations. And we take this and we provide it as a dashboard that's interactive. So I can click through this gross margin worksheet and I can get into the underlying data or highlight specific values. It's much more interactive than just like a PowerPoint chart. And I can figure out what it is that I'm looking for in terms of, what is the underlying transactions for that. I can filter it. Total revenue by business unit. And so I can slice and dice this and create interesting things to get down to the different values that I'm looking for. All right, so visualizations. We're going to come back to those in our lab on Wednesday. Okay, so questions that you guys have. Again, this is just a high overview of different types of models that you're going to be encountering, as well as different ways that you can express and share this information. There are a lot of different ways that you're going to be working through this. When we come in on Wednesday, I have some transactional data that's looking at sales and purchases that we're going to slice and dice to look at from here's some questions that we would ask as an auditor versus a management accountant versus a financial accountant that the data can help us answer. Okay. So we have a few extra minutes. If you need some lab time to work on your ETL lab, I can help answer some questions for the next 15 minutes. Otherwise, if you are done, you're welcome to take the extra time.